Hey everyone, so today we're going to learn about mass and volume. Mass is how much stuff you have, and how do we measure mass? Well, by finding its weight. Mass and weight are different, so they're not the same. Weight is how much stuff you have times the pull of gravity, that's your weight. But we live on a planet with gravity, so whenever we find the mass of something, we find the weight of it. So, but in any case, we find the mass of something with a triple beam balance. So a triple beam balance has the word triple in it, right? Which means that you have three beams that you're looking at. So when you're looking at a triple beam balance, you have the three beams in the middle. You have a balance mark with the little number 0 next to it, and you have an adjust knob on this side. So the first thing you want to do is make sure that the little white line that is on the side with the beams matches up with the 0 marker on the right. If it's too low or too high, then you adjust the little knob over here until it's just right. Okay? So once it is at 0, you put the object onto the weighing pan, and then you're going to slide the 100 grams. Okay? So anytime that the white line is up, you want to put the weight further and further to the right until it's down. And you've all done this before. So you put the 100 grams, then the 10 grams, and then the 1 grams. You want to make sure it's as exact as possible. You want the little mark to line up with the 0 on the right. And so how do you add it all up? You do the hundreds times the tens times the ones. The ones have 0.1 on them, so you are going to weigh to the 10th gram. So here's some examples here. So here you have 100, you have 50, and you have 4 point something. These little notches are tenths of a gram. So let's say this is 100 plus 50 plus 4.4. So what do you get? 154.4. Sometimes it helps to put the tenths of the grams for the hundreds and the tens as well. And what are your units? Grams. Let's do example number 3. So you have 500, 60, and then 2 point. How many notches over? Let's say 0.3. Okay, so let's add these all up. You have 500.0 plus 60.0 plus 2.3. And what do you get? 562.3 grams. These examples down here let you kind of do it in reverse. So 476.5. So the first number, the hundreds are 400. So you would have a weight that's like right there. 70. And then 6.5. So the 6.5, both numbers are on the ones one here. You have 6.5, halfway between 6 and 7. And that would be your weight there. 476.5 is if you drew on the triple beam balance. All right, now let's talk about volume. Volume is the amount of space an object takes up. So whereas mass is how much stuff you have, volume is how much space it takes up. And we can measure the volume of solids, liquids, and gases. So how do you find the volume of a solid that is regular in shape, meaning that it's got flat sides? Well, all you do is length times width times height. So let's look at this example. Let's say you have an object with a length of 1, a width of 2, a height of 5. And it doesn't matter what you call a length, a width, or height. Just that there's 3 dimensions. That there's this dimension, and that dimension. All right, so when you multiply them all, length times width times height, 1 times 2 times 5 is 10. But then you have to multiply the units as well. Centimeter times centimeter times centimeter is centimeter cubed. And so that's how you find the volume of a regular object that's a solid. How do you find the volume of a liquid? Well, you use a graduated cylinder. You put the liquid into a graduated cylinder or beaker, and then you look at where the bottom of the line is. So whenever you have a liquid in a graduated cylinder, there is this little dip in the top of the liquid, and that's called the meniscus, the curved top. So you look at the bottom of the meniscus to see what your volume is. So in this example here, it dips down right at 20, okay? And so your answer is 20, and what do you measure in? It's in milliliters. Usually you'll have milliliters. So if we were in the classroom, you would want to crouch down so that your eye was at the same height as the liquid. So you don't want to look from above it or below it because of the way that you have the liquid inside of a glass, and you might be wearing glasses. You want to make sure you're at the right height so that you get the most accurate reading. So how do you find the volume of an irregular object that is solid? So you fill up your graduated cylinder. It doesn't matter to what number. Let's say you fill it up to, say, like 20 milliliters. And then you record it. And then you put that object into the liquid. And you see how much higher it goes up. The difference between the beginning and the end tells you how much space this took up, because the liquid had to go somewhere. So when you put this object in it, the liquid went up, okay? So let's say it went up to 25 milliliters. So you started with 20 and it went up to 25. What's that difference? Well, it's 25 minus 20, it's 5 milliliters. So you're looking for the difference between the two to find the volume of that object. So if we looked at this one, right, it's water level after minus water level before. That's your volume of an irregular solid object. So if we look at this example with this toy dinosaur, so you have this volume before, and you have this volume afterwards, right? You're looking at the bottom of the meniscus. If you're trying to figure out what these little notches go by, the easiest way is to add up how many lines there are between them. So you have 1, 2, 3, 4, 5. So you have 5 lines divided by, what does it go up to? 1 to 2. So you jump all the way up to 1. Or I'm sorry, it's the reverse. So it's 1 line, or it goes up by 1 milliliters per 5 lines. So that means that each line is, what's 1 divided by 5? So it is 0.2 milliliters for each line. So if you go here, you have 4, 4.2, 4.4, 4.6, 4.8. How did I get the 0.8 milliliters? Well, each little line is 0.2. So I went by 0.2s, 4.2, 4.4, 4.6, 4.8. Now on this other side, you have 5, and then you're going to go up by 0.2 milliliters. 5, 5.2, 5.4, 5.6 milliliters. So then all you do is you use your formula. Volume after minus the volume before is your volume of the object. So you do 5.6 milliliters minus 4.8 milliliters, and you get 0.8 milliliters. And that's your answer for that. All right, so let's do a few examples of volume. So if you're looking at the volume of a liquid, again, you just look at the bottom of the meniscus. So here, these go by ones, so this is very easy. This is just 35 milliliters. That's your answer. Let's say you didn't know these went by ones. All you had to do was add up how many lines you had. And so you have 10 lines. And how many milliliters does it go up from 30 to 40? It goes up by 10. So that means each line is 1 milliliter per each line. Okay. So then let's do some regular object examples. So length times width times weight. So your volume is length times width times height. So you have 7 centimeters times 8 centimeters times 10 centimeters, which gives you 560. And then centimeters times centimeters times centimeters, my bad, is centimeters cubed. Or if you want to do this example, so you would do volume is length times width times height, 6 centimeters times 3 centimeters times 7 centimeters. So that would be 18 times 56, what is that, like 126? Sound like that. You can check my math. And then you do centimeter times centimeter times centimeters, centimeters cubed. And very last example here, let's find the volume of an irregular object. So these go by ones, which makes it easy for us. This is 19 centimeters before, or 19 milliliters. It's liquid, so we use milliliters. And what is the liquid volume after? It is 29 milliliters. So how do we find the volume of this little aluminum cylinder? You do volume after. So what's the water after? Minus the water before. Or the volume before. So it's 29 milliliters minus 19 milliliters, which equals 10 milliliters. Okay, so that's how you find the volume of an object and the mass of an object.